Welcome to SanfordFlipMath. This is the at-home edition. We're actually recording a law of sines video since it was not already in the list. This would be the second lesson for law of sines. This is what is often referred to as the ambiguous case or the unclear case. This is the two triangle problem. Way back in the day when you were in geometry, you learned a whole list of ways you can show triangles are congruent. For instance, side, side, side is legit, side, angle, 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 side. Those are all ways to show triangles are congruent. Well, it turns out that side, side, angle, or its reflection, side, side, angle is not a way to show triangles are congruent because with that information, there are two triangles possible. And that is what we have here. So just to kind of draw attention to that, pardon the pun, if I look at this side and this side, note the angle is not between them. So the A is not between the two S's. This is a side-side angle arrangement of information. Now that doesn't mean this triangle doesn't exist. That doesn't mean we can't find out information about this triangle. It just means that there is potentially more than one triangle possible. I will say from the outset, sometimes it works out that the second triangle doesn't make sense, so you can dump it. But what my plan is, what our plan is going to be, is just to proceed like there are two triangles. And if we turn out to find, if it turns out one doesn't work, then we just go, cool, only one, or maybe none, as it were. Okay, so we're just going to start the process here of solving this triangle just like we always would. Okay, so I know an angle length and the opposite side, B and B. So I'm going to do sine of 25 over 5 equals, and we're going to go the side we know is C. So I'm going to do 10, and this will be the sine of C. Okay, so we're going to solve this for angle C. So I'm going to cross multiply. And we'll divide by 5. So the sine of C is going to be equal to all of this. Okay, so I'm going to type that in. Hopefully you can see this on here. I'm going to try and not have to zoom in and out a lot, but we'll see how it goes. Make sure you hit the close parentheses on there, divided by 5. Okay, so 0.84, 0.845, bunch of stuff. Okay, to get the actual angle, this is the sine of the angle. So to get the actual angle itself, we're going to have to do inverse sine. Okay, and if you're working on TID4C or CE, you can, or a newer TID4, you can actually up arrow and hit that and do the inverse sine. Or if you're on an 83, you'll have to do like second answer, second the negative sign. Okay, so 57.69728, blah, 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 blah. Okay, so angle C is 57.697. Okay, now I'm going to stop the process of solving this triangle for just a hot second and take a little trip down. Dang, did we even think about that lane? Okay, so we just did inverse sine and we got 57 point something degrees. Okay, but we did inverse sine of a positive angle or a positive number. Well, based on all students take calculus or a little mnemonic, we know sine is also positive over in the second quadrant. So that 57-degree angle could have been over there. This really could have been, angle C could have been 180 minus that 57 as a possibility. Well, enter the two triangle problem. So what's happening is, what I actually have drawn in this little triangle I drew, this is really the 180 minus the 57 angle, and it's possible that angle C was over here and this was the 57-degree angle. Okay, so there were two possibilities. I don't need you to draw it, I just need you to be aware, and I need you to be able to solve for that second possibility. Now, so what I'm going to do is go ahead and figure out this other version of angle C. So I'm going to say 180 minus, because it's in the second quadrant. So this becomes 122.303 if you're rounding to the nearest 3 decimal places, which is what we end up doing. All right, so just again, what has happened is I am running two separate triangles at the same time. all the given information is true for the first triangle. All the given information is true for the second triangle. But there will be different answers for angle C and side C, or I'm sorry, for angle C, side A and angle A in these triangles. Okay, so the way this starts is it was an SSA arrangement of information. That means that it's possible that I could have two legit triangles. The first thing you can do, all you can do is using the law of sines is solve for that angle. I solved for the angle. It's also possible that I have a second quadrant angle that also works. This is normal. This is a possibility, okay? All right, so what we're gonna do then is finish solving based on this. And it's just, it becomes two problems, that's all. It's not a big deal. Okay, so here's angle B, here's angle C. To get angle A, I can do the 180 thing. So 25 plus the 57 point whatever. And so I'm gonna go ahead and grab that 57. Okay, so this is where if you have a TA83, maybe you want to save this as C. So you can, so just a reminder how to do that. The store button is down here. So this number, I'm going to push store, and I'm going to call it angle C. Well, angle C, or I'm just going to call it C. C is the letter above that, so I'm going to do alpha program. And when I hit enter, it'll save it there. Okay, you don't ever need to replace it. You don't ever need to clear the memories or anything. It'll just live there until you replace it with something else. All right. I don't think, if you have an 84 that's up to date or an 84 that's newish, then you don't need to do that. All you can do, all you have to do is do the up arrow thing and then hit enter, and it'll grab whatever number you want. Okay, so again, I'm going to take this last number plus 25. Okay, those are the two angles together so far. And I'm going to do 180 minus that answer, and this is my angle A, so 97 point whatever. Okay. So A equals 97.303 degrees. I'm going to finish this triangle before I pop back over to the other triangle. Okay, so I'm going to use, so now I know all three angles. Here's angle A, here's angle C, angle B was given. Okay, I already know side B and side C. All that's left is side A. Okay, so I'm going to do sine of A. And I'm really going to use the whole number. I'm not going to just use this rounded version. Over, I don't know yet, equals, I'm going back to the B's because I have them and they're clean. Okay, so again, I'm going to cross multiply. And then I'm going to divide by the sine of 25. Okay, so now A equals, and I need to type this in. Okay, so I'm doing 5 times the sine of that number divided by, and again, I close parentheses, sine of 25, 11.735. Okay, and my sides were in inches, so I'm going to write inches there. Okay. All right, so that triangle is done. Okay, so I have BB, C, C, A, A. Okay, I have all of that. Okay, I just took attendance. I wanted to make sure that I have everything. Okay, so the rest of this is just like what we just did. I need an angle A, and so I'm going to do 180 minus the 122 point whatever plus the 25. Okay, so I'm going to go hunting. I'm going to go up the chain here. Okay, so there's my 122. I'm going to hit enter. Plus the 25. I'll do 180 minus that number. Okay, and this is my new angle A, 32.697 degrees. Okay, so that's angle A. Okay, and again, I need side A. So I have to redo everything. Okay, the only thing that I got from the original inverse sine was the 180 minus. Okay, so that's for that first angle. All right, so after this, I have to redo everything. I can't just do 180 minus my other angle A. I have to do 180 minus these two angles. And then again, to do side A, I have to redo the law of sines. So yes, it's a pain. I'm sorry. It's just is what it is. Okay, 25/5, and I'm still on screen, so that's good. Okay, so again, I'm going to cross multiply. So all the math I'm doing right now looks just like the math I just did. It just has this other version of the angle in it. Okay, and that's a times the sine of 25. Okay, and I'll divide by the sine of 25. Okay, so A equals, and I'm just going to retype that. And if you want to do the fancy fractiony looking thing, you can. It doesn't matter. Okay, and again, close parentheses, divided by sine of 25. We're coming into the home stretch. Boom, chakalaka. There we are, 6.391 inches. So if you have units for your sides, please use them. The angles, because this is really geometry, will be in degrees. Okay, and we're good to go. So again, we had both B's. Here's a C and a C, and here's an A and an A. So I'm just taking attendance. Okay. All right. So just to let me see if I can get all of this kind of on screen at the same time. If you want to try and grab a screenshot of it, I don't know if I can get it all. I really can't. Well, let's try it one more time. All right. I don't have the given information there though. Sorry. But hit pause, do a screenshot, whatever. All right. So this is that. All right. Just to kind of recap what happened. If you have side-side angle, so basically what it will look like in the list is two matching letters. Like A, and then another side. Or it might be C, C, and another side. Okay, so that's how it's going to look in the list. If you have a side-side angle, so two sides and an angle, not the angle between them. When it's SAS, you have all three letters, like it'd be A, B, and C, or something like that, or A, B, C. You know, so if it's SAS, that's a different setup. That'll be used for law of cosines will be used for that situation. So if you have side-side angle, you are going to use law of sines, and the very first angle, the first thing you're going to find is an angle. That angle will be in one triangle, and its supplement will also be in another triangle. So like, for instance, if you solve for angle A, then there will also be a 180 minus A, and that will create two different triangles. Okay, so you use this version of angle A, solve the rest of the triangle. 180 minus that version of angle A, solve the rest of that triangle. That's the short version. That's kind of the moral of the story. Okay, so anytime you have two sides and a non-included angle, expect two triangles. It's possible that when you go to find that third angle, it doesn't make sense because it ends up more than 180 already. If that's true, then cool, you're done. You can stop at the first triangle. Okay. All right, that's it. I'm stopping at anything after this, and I'm just rambling for no reason. So welcome to Sanford FlipMath Home Edition, the first pre-calc video that we're putting out like this, and much love. It's been fun. All right, bye.